In this video, we're going to look at some common structures of compounds that are derived from the benzene ring or the benzene compound, as you might want to call it. Now, you really need to be very familiar with these structures, and especially the common names of them, because most obviously you would actually deal with them within the course of the organic chemistry that you would deal with within your second year. So let us look at them. Now, of course, we are going to start with the first one, which is going to be this one. We want to see what is the names of these compounds. So if you know how to name them, feel free to pause the video and try doing that by yourself. Okay, so let us start with these ones. Now, what is the names of these compounds? So we're going to start with the first, which is this one. Now, you know that, of course, this is the benzene ring. It could also be written this other way. You could also write it this way. That is as a result of the resonance or the delocalization of the pi electrons which are present within that ring. So, of course, this is benzene. So the name should actually come off easy for this one. That is benzene. Now, what is the name for this one? So as you can see, we actually have two benzene rings. Now, should we call it dibenzene or what? So basically the name for this one, the common name for this one is naphthalene. So that is going to be the name for that one. And for this one, what is going to be the name? So this is anthracene. Now this one is phenanthrene. So if you see it, you just know that you have a phenanthrene right there. Now what about this one? Now as you can see, we actually have anthracene here and one benzene ring on top on the other position. So we could actually say that we have a 1,2 benzanthracene. I do not really know how to pronounce that, but hopefully you get the point. So this is 1,2 benzanthracene. Hopefully you get the point. So that will be the name for this compound. How about this one? So basically this is benzoic acid. Now here we have two of the carboxylic groups on the benzene ring. So what is going to be the name for this one? So this basically should be a benzene dicarboxylic acid, But of course, that is going to be the conventional name. We're talking about the common name for this compound. So let me just write the conventional name. That is going to be benzene dicarboxylic acid. But the common name is going to be phthalic acid. So you just need to hold that at the back. Now let us try out some more. So let me write out two more. So I think let us just get on with these ones already. So what is going to be the names of these compounds? Now majorly we know that this basically should belong to the homologue of alcohols. But what will be their individual common names? So for this one, we actually have benzyl alcohol. So this is got to be benzyl alcohol. Now this part, this please actually has a CH2 group. So just bear that at the back. Now this one, this is called phenol. Now how about this one? So we actually have a phenol if we actually removed this OH group from it. Now that we have another OH group on it, what is going to be the name? Is it going to be hydroxyphenol? Well, that is quite correct. But bear at the back, we're actually dealing with the common names and not the conventional names. Now, before we go on, you need to know that if you have a benzene ring with any group on any position, so let us say we have an OH group here. Now, all the other positions would actually take their names as a result of one of the substituent or a kind of branch that is upon any of the carbon atoms. So in this place, we're going to have it as the para position. So this and this will be para positions. So if you actually have another group here, let's say chlorine group here. Now we know that this is a phenol. So if we have a chloride group on the position here, we're actually going to say this is a para chloro phenol. Now that is as a result of the position where the chloride atom is. But there is also other positions with their names. So here you have this to be the ortho position, and here is actually the meta position. So this is ortho and this is meta. And for this one, we have it to be the para position. So just hold that at the back. Now with that, I could actually call this using one of these command forms. So we know that this is going to be the para position. So this should be the ortho position. So I could also say this is an ortho hydroxyphenol. So this is a very correct name that I could actually give to this compound. But then we're talking about the common names and not the conventional. So let us look at what the conventional name will be. Now this is actually supposed to be catechol. So anytime you see this, just know that you have a catechol right there. How about this one? What is going to be the conventional name and the common name. So for the conventional name, we know this is a para position and this is an ortho. So this should be a meta position. So that basically is M-hydroxy. So this is M-hydroxyphenol. That is basically going to be the name of it. Now this is also called resorcinol. Now how about this one? What is going to be the name for it? So this one is going to be hydroxyquinone. Hydroxyquinone. Now quinone is actually written this way. So this is the structure of quinone. So if you reduce this, you would actually change this to hydroxyquinone, which is actually the same thing as quinol. So just know this could also be called quinol. Okay. So this would get reduced. There would also be some here, and you would have this. So that is basically how the stuff is formed. Let us go on. Let's look at some more. Now, what is going to be the structure for the following compounds? You have picric acid and aniline. Oh, and I think I need to write another one. Aminophenol. Let us write out another one. So let's say you are given another one. Benzamide. And we have phthalimide. And if you can actually do it, you could pause the video and try doing it by yourself. So let us start with this one. The structure of picric acid. So first of all, you know that there must be a benzene ring. And then it will actually carry 3 nitro groups at these particular positions. So this is what you're going to have. And there will be an OH group at this position. So this is basically the structure of picric acid. How about aniline? Now aniline is basically a benzene ring with an amino group on any position at all. Now aminophenol. So we need to have an amino group and a hydroxy group on the benzene ring. So stuff should basically look like this. So this should be NH2 and I'm going to have OH there. So this is the structure of aminophenol. How about benzamide? What is going to be the structure? So that should be a benzene ring with an imide group. So this is basically the structure of benzamide. Now phthalimide is the type of benzamide where there are actually 2 of the imide groups. So that is going to look like this. So you're going to have one imide group here and another over here. So that's typically the structure of phthalimide. How about these ones? Try to draw the structures of these ones. So what is going to be the structure for the following compounds? So for this one, we have a benzoyl iodide. So we need to have a benzene ring. And anytime you have a benzoyl and not a phenyl, that means there must be an additional carbon atom after the benzene ring is drawn. So that is what we should have basically. Now I'm just going to make up this, and then we're going to have something this way. So there's going to be a double bond O and an iodine here. So let me redraw that. So this should be, so this is going to be an O there, and we're going to have an iodine here. So that is basically the structure of benzoyl iodide. So there should be a carbon here. That is basically the structure. Now take note, you always need to have a carbon atom after the full benzene ring has been drawn. And for the benzoyl iodide, you need the carbon atom to be a carbonyl carbon. So that is going to be a C double bond O with a single bond stretching forth to the iodine atom. And here we have benzene sulfonic acid. So that is going to be a benzene ring with SO3H. This is basically the structure. How about toluene? So that is basically a benzene ring that carries a methyl group on top of any position, as far as that is the only substituent that is present. And you could also have it in any other position as well as the sulfuric acid. How about xylene? What is going to be the structure for xylene? So xylene should have a para-methyl-toluene, or you could also have it as 1,4-dimethylbenzene. So this is going to be a CH3, and we also need to have another CH3 over here. So this is 1, 2, 3, and this is the fourth position. And if you wanted to name it in conventional form, that is going to be 1,4-dimethylbenzene, but we have xylene as a common name, which is basically what we're trying to deal with in this video. So let us try out some few more. So in here you have another one, which is benzophenone, and there is also another, cumene. So what is going to be the structure for these compounds? So for nitrobenzene, we got to have a benzene ring that carries a nitro group. So that should be this way. Benzophenone. So we need to have a benzene ring that carries a carbon with a double bond O, and then we're going to have a phenyl group, which is going to be this. So this is basically the structure for benzophenone. How about cumene? Now cumene should carry a benzene ring, and there should be an isopropyl group. So this is what we're going to have. This will be a CH3, and here we're also going to have a CH3. So that is the structure for it. To rewrite that. Now anisole. So anisole should be drawn this way. So this is going to be a methoxy. This is a methoxybenzene kinda. So we just have some few more to look at. So what is going to be the names for these ones? So let us start with these ones. Now what is going to be the names for these compounds? So let us start with the first. Start with this one. So this is basically a benzaldehyde. Benzaldehyde. This is actually an aldehyde because it has this aldehyde group. Now this one, this is a phenyl halide or a halobenzene because you have the X here, which basically stands for halogens. It could be a bromine, a chlorine, an iodine, or a fluorine. So just bear at the back that X basically means the halogens within organic chemistry. So this is halobenzene or benzyl halide, whichever way you want to call it. How about this one? So basically this should be a diphenyl. If you were asked to draw diphenyl, this is the structure. Now this one, we have two phenyl groups which are basically separated with an oxygen atom. This is basically going to form the ether form of a homolog. And so that should be diphenyl ether. So this is going to be diphenyl ether. How about this one? What is going to be the name for this structure? So this is basically PCM. PCM, that is paracetamol. How about this one? So this is going to be salicylic acid. So we just need to try some few more and that ends this class. So what is going to be the structure for aspirin? So aspirin looks this way. This is aspirin. How about acetophenone? Now acetophenone will be this way. So just bear it at the back that this is acetophenone. How about benzene diazonium chloride? So benzene diazonium chloride is written this way. So there is actually going to be a negative charge here. there is going to be a positive here. So this is benzene diazoxide chloride. So that brings us to the end of this class.